All right, so in 4.1, we kind of introduced the idea of polynomials and classifying them. Now we're going to move into some operations, in particular adding and subtracting polynomial expressions. So our essential question we want to be able to answer is, how do you add and subtract polynomials? So polynomial addition using Algebra Tiles. All right, so looking at Algebra Tiles here, so our first one we have 2 of these x squareds, and we have a single x, but it is a negative x. And then our second one, we have 1x squared. We have 3 x's, and then a single 1, and it is a negative 1. So then what we want to do is we're just going to combine the terms that look alike, which, nice thing about Algebra Tiles, you can visually see what looks alike. So we have our x squareds. So there's 1, 2, 3 of those x squareds. Then we have our x's. And there's 4 of those blocks, and then we have our 1's. Now we see here we have a negative x and an x, so those two together cancel each other out. And so then what we're left with is 3 x squareds, 2 x's, and then 1 negative 1 tile. And so that's what our answer is when we add those together. Now, we don't always want to use algebra tiles. They are helpful. You can draw them out as well if you don't have the technology to use it to visually see how things go together. But it's not always the quickest method. So we have a couple other methods here. So one of them is using a vertical method, which you learned like in elementary when you did some basic stuff of 2 plus 3 is 5. You just add it straight down. So we'll do similar thing here. So I have 5x squared plus 2x minus 1, and then I line up my like terms, so 4x squared minus x plus 2. Notice that my x squareds are vertically aligned, my just x's are vertically aligned, and my coefficients or my constants are vertically aligned. So then I just add my numbers together. So 5 plus 4 is 9, and I still have an x squared. 2 plus a negative 1 is 1, or 2 minus 1, either way. So that is just 1x, which we write as x. And then negative 1 plus 2 is a positive 1. Now, same thing on example 3 here. We get 3y cubed plus 2y plus 1. Now, one common mistake with this happens right here is students will just write these down, lining up the terms. And the issue is we have a y cubed lined up with a y squared, and then a y lined up with a constant. So that's not right. So then what we need to do is we need to rewrite that. So I have a 3y cubed. One thing that is helpful is maybe put placeholders in. There is no y squared, so I'll put a 0y squared. And then there's a 2y, and then there's my constant. So then this one has no y cubed, so I won't start there, but I will start at y squared here. There is no y, so I put 0y there, and then a minus 1 there. Now we're going to add those together, so we have a 3y cubed. 0 plus 1 is 1y squared plus 2y, and I wrote this one wrong. This should be a minus 1 there. And plus 1 minus 1 is 0. So our answer is 3y cubed plus y squared plus 2y. Now, adding horizontal, which is the most common method, is you write these out, and I have 5x squared plus 2x plus 1 plus a negative 4x, which is just negative 4x squared, minus x minus 2. Now really what we're doing here, we're just looking for like terms. So the way I go about it is I go, okay, I have an x squared. I look for are there any other x squareds? There is. Then I just look at the coefficients. 5 minus 4 is 1x squared. And I cross them out, just help me keep track. You don't have to, just an organizational tool that you can use. And then I go to my next term. I have an x and I have an x. So 2 minus 1 is 1. So I get 1x. Cross those out. And then I have my constant 1, and that combines with my constant negative 2, which is a negative 1 there. All right, so reflection is a sum of two polynomials, always another polynomial. So go ahead and write down your answer for that, and we'll discuss that when you come back into class. All right, now subtracting. Okay, so notice we now have a negative. So write this down. I have 5x plus 2. And then I'm going to be subtracting. Now here, I have an x squared. So that's going to go over here before my x. And then a minus 3x. And then a plus 4. Now with subtraction, we have an issue because we have this negative out in front. So I need to distribute that. So that makes that a positive 2x squared. Distribute there, that makes it a positive 3x. And distribute it there, and that makes it a negative 4. So kind of rewriting all that so it looks a little cleaner. As we end up with a positive 2x squared, a positive 3x, and then a negative 4. And now it's an addition problem like we did before. So it's my only x squared. 5 plus 3 is 8. 2 minus 4 is negative 2. So subtraction problems is really just an addition problem after you distribute the negative. So let's look at our example 7 here. I have a y squared plus y minus 1. Now I'm going to distribute this negative first just to save. So that gives me a positive 2y squared. That gives me a negative y there, and then a negative 1 there. Now everything's lined up properly. Now it's addition problem, so we just combine like terms. 1 plus 2 is 3. 1 minus 1 is 0, so there is no y, and then negative 1 and negative 1 is a negative 2. And then there is our answer. Now subtracting horizontally. Similar concept, we're going to distribute the negative. So my first term has these parentheses. I don't need them there anymore. There's nothing that actually happens to them. The second set, it's important because that tells us the negative goes to all of those. So I get a negative 2q squared minus q, and then that becomes a positive 4. So just like we did before, we look for like terms. So I have a q squared and q squared. So 2 minus 2 is 0, so there is no q squared. And then I look for q's. So I have a negative and a negative, so that becomes negative 2q. And then my constants, negative 8 and 4, gives me negative 4. And then number 9 here, so my first term, 2ab minus b plus a. Distribute the negative for the second term. Gives me negative 2b squared minus b minus a, and then a negative 4. Now we're looking for like terms. So I have a 2ab. Is there any other 2ab? There is not. So then we just write that down. Then I have a b and a b, and negative b and a negative b is a negative 2b. I have an a and an a, so 1 minus 1 is 0, so my a's just go away. Next is the b squared. Are there any other b squareds? There is not, so I go ahead and write that down. And then I have one constant. It's the only one, so it doesn't combine with anything, so that one just gets written down as well. So if there is nothing to combine it with, we just write it down as is. All right, so a little reflection here. Is the difference of two polynomials always another polynomial? Again, have your answers down. We'll discuss it when we come back into class. All right, so modeling here. So the first factory makes a profit of negative 0.03x squared plus 20x minus 500. And the second makes negative 0.04x squared plus 25x minus 1,000. What is the polynomial modeling the box company's total profit if both factories make the same number of boxes? So then what we would do is we'd just write these down. And so since we want the total, we're going to add those two companies, how much they make together. So I get plus a negative 0.04x squared, which I will change the positive and negative, just make it a negative. And then 25x minus 1,000. Now combine like terms. So I have an x squared and an x squared. So it gives me negative 0.07x squared. I have an x and an x, so that gives me 45x. And then negative 500, negative 1,000 gives me negative 1,500. All right, so 12, the revenue made by a car company from the sale of Y cars is given by 0.005y squared plus 10y. The cost to produce Y cars is given by the polynomial 20y plus 1 million. Write a polynomial expression for the profit from making and selling Y cars. Find the profit the company will make if they sell 30,000 cars. So this portion here is how much they make, and this is a cost. So you take revenue and you have to subtract cost. So profit equals your revenue minus your cost. So in this case, our profit, we'll call P, equals our revenue, which is 0.005y squared, plus 10y, and then we need to subtract our cost, which is 20y plus 1 million. Now what I should have done initially is not written that parenthesis, because the most common mistake students make is they don't put the parenthesis and they only get the negative 20y, but we're subtracting the whole cost, so we need to put parentheses around that, which means we then need to distribute that negative. So that gives us a negative 20y and then minus 1 million. Now combining like terms here, we get P, our profit, equals, there is no y squared, so we get 0.005 y squared. There are two y's, so 10 minus 20 is a negative 10y. And then we just have one constant, which is 1 million. Now they want us to find the profit if they sell 30,000 cars. So what we'll do is we'll just substitute that value in for y. Okay, and easiest is use your calculator at this point to figure that out. And that will give a profit of $3,200,000. Okay, so just be careful on that one. Make sure we're paying attention. Are we adding the two together like we did with the factory, or are we subtracting because we're taking the cost away from something? All right, so several your turns here, so 13 through 16. Go and try those on your own. And then our essential question, how do you add and subtract polynomials? Don't forget to do your quizzes as well. We'll go over all of this when we come back into class. Answer any questions you have.